Hi, welcome to the last video for lesson 8.3, complex numbers in polar form and de Moivre's theorem. In this one, we're talking about how to find the root of a complex number. And this actually is a rather complicated process, so try and watch closely. So basically, any complex number has n distinct nth roots. So if I want cube roots, I'm going to have 3 answers. If I want 4th roots, I'm going to have 4 answers. If I want 6th roots, I'm going to have 6 answers. So the number of the root is going to tell you how many answers you need. Okay? Now, for the formula, you take your modulus, your r value, and you do that root of it, and that's what this is. This is 1 over n. That's the root written as a fraction. And then it's the cosine of the argument plus a full circle over n. You'll notice the 2k pi looks familiar from chapter 7. Plus I sine, and then the argument plus 2k pi over n. So one other thing that I wanted to note to you is that sometimes it's easiest to change the radian values for your theta into degrees. And what that means is that instead of 2k pi, you're going to change that to 360 times k. And sometimes that's easier because it just simplifies some of the fraction work that you would be doing. So in our first example, I'm going to do that. I'm going to keep it in degrees. And it's just going to be theta plus 360k over n. And in the next example, after that, I won't. So let's take a look. It says find the 3 cube roots of z equals 2 plus 2i and graph those roots. Now notice, again, this is given in rectangular form. We need to find the polar form of this. Okay, so for r, it's going to be the square root of 2 squared plus 2 squared, which is the square root of 8, or 2 times the square root of 2. Okay, I'm just going to write this as 8 to the 1/2 power. And I'll deal with that later. For theta, we have tangent of theta equals 2 over 2, which is 1. So theta is pi over 4. But remember, I said I was going to work in degrees in this, so it's 45 degrees. Now what I'm going to do is take all of this and put it up into this formula. So I have W equals 8 to the 1/2. Now this should be 1 over 3 because I'm finding cube roots. So 1/3 times the cosine. Now my theta was 45 degrees plus 360k over 3 plus I sine of that fraction as well. Okay, now what I'm going to do is pick values for k. I'm going to start out with k equals 0. And we always start at 0 and count up from that. So this is going to be 8 to the 1/6 power, because remember we multiply those exponents. So it's 8 to the 1/6 times the cosine. Now this is just going to be 45 plus 0, which is just 45, divided by 3. So it's 15. Plus I sine of 15 degrees. And I should mark that that's degrees. Okay. Now again, because this was given in rectangular form, I can put this right into a calculator and get rectangular form. It will be an approximate value, which happens to be about, let's get it off my page, 1.37 plus 0.37i. Okay? Now with k equaling 1. I'm still going to have 8 to the 1/6 power times the cosine. Now what's going to happen is I'm going to have 45 plus 360 times 1 and divided by 3. So from my calculator, I know that that comes out to be 45 plus 360, which is 405 divided by 3, which is 135. So this is the cosine of 135 degrees plus I sine of 135 degrees. And again, I'm going to give this in rectangular form. So I just put that into my calculator, and it comes out to be, let's see, -1 plus I. And last for k equals 2, because notice 0, 1, and 2, that's 3 answers, and that's what I need for 3 cube roots. So I have 8 to the 1/6 times the cosine, and oops, I went off the page, times the cosine. Now, in my formula, I'm going to do 45 plus 360 times 2. So 45 plus 360 times 2, and then divided by 3, which is 255. Now, also be careful, because if you're using degrees here, you want to make sure your calculator is in degree mode when you get these approximate answers over here. That one comes out to be negative 0.37 minus, and that's 1.37 I. Now, also notice that I didn't just type this whole thing in. Notice this I makes it impossible to do that. So I did 8 to the 1/6 times the cosine of 255, and I wrote that down. And I did 8 to the 1/6 times the sine of 255. I ignored the I when I wrote that final answer, but in order to get it into this subtraction form, I needed to do it in that way. So these are my 3 answers, and the last thing said to graph these. So basically what it's going to do is it's actually going to be on a circle. So 1.37, let's say this is 1.37 would be here, and 0.37 would take me there. I have -1, 1, which would be like there, and I have -0.37, -1.37. So these are my 3 answers, and they actually end up on a full circle. If I was to graph them properly, it would make an actual circle here. There would be points on a circle. And that's what happens with these. They will always be points on a circle. Okay, so let's take a look at one more example. Okay, they want us to solve the equation z to the 6th equals -64. Okay, notice what they've done. They want us to solve this. I need the 6th root of -64. And that would be an imaginary number, because I can't do the 6th root of a negative number. That's like the square root of a negative number. It's imaginary. Okay, so what I'm going to do is I'm going to turn this into polar form. So for my r, I'm just changing this. So it's 64 squared plus 0 squared and the square root of that, which is just 64. And for theta, I know tangent of theta equals y over x. Now, also notice that I can get a hint from graphing this. This is just going to be on the x-axis. -64 is over here. So I don't really need to do this. I could do that it is y divided by x, so 0 divided by -64 is just 0. And I'd find out that theta is pi. I don't necessarily need to do that if I just graph it and say, hey, look, -64 is at -pi. Okay, so now when I write my final form for this, I'm going to have k equals 64 to the 1/6, because I'm doing 6th roots of these, times the cosine of pi plus 2k pi over 6 plus I sine of pi plus 2k pi over 6. Okay, now the 6th root of 64 is just 2. So this can be replaced with just a 2. Sorry, this was supposed to be a different variable, w. Now I'll pick my k values. If k is 0, I'm going to have 2 times the cosine of, now notice this is going to be 0, so it's going to be pi over 6 plus I sine of pi over 6. Okay, and then you can go ahead and change that back into rectangular form. For the sake of time, I'm not going to do that. Let's do k equals 1 now. So I have 2 times the cosine. Now this is going to be pi plus 2 pi, which is 3 pi over 6. 3 pi over 6 reduces to pi over 2. So pi over 2 plus I sine of pi over 2. For k equaling 2, I'm going to get 2 times the cosine. Now this is going to be pi plus 4 pi, which is 5 pi over 6, plus I sine 5 pi over 6. For k equaling 3, I have 2 times. This would be 6 plus 1 pi is 7 pi over 6, plus I sine 7 pi over 6. And for k equaling 4, I get 2 times the cosine. 4 times 2 is 8, plus 1 is 9, so that is 9 pi over 6, which is 3 pi over 2. 3 pi over 2, plus I sine 3 pi over 2. And the last one, k equals 5, I get 2 times the cosine. Now 5 times 2 is 10, plus 1 is 11, so it's 11 pi over 6, plus I sine 11 pi over 6. Notice I have 1, 2, 3, 4, 5, 6 answers. Those are the 6 answers that would work in this equation. What to the 6th power equals negative 64. That's it for this part of our lesson. Let me know if you have any questions, and I'll talk to you soon.